All right, so. Bill. We'll bring up your thing now.
After all your switching, bring up the next one.
It's practice. It's practice. Somewhere here. Nice. Which one are you?
The first one.
This one?
Yeah.
Okay. All right, good. Share. That one. Share. Function F5. Function F5. Can we see it?
Yeah.
All right, great.
We're only seeing the PowerPoint, not the. Oh, there it goes. Oh, there it goes.
Bill,
Okay.
it's your turn. Everybody, Bill, it's in the handbook.
Handbook. So this month, I decided I was going to look at the section expired stars. And what better one from the handbook to look at than Cygnus X-1? And
I heard you say Sean Connery.
and the background for the presentation is the star field with Cygnus X-1. And that's the photo credit there for it. So, Cygnus X-1 expired stars 304 in the handbook. There is a Canadian Toronto connection to Cygnus X-1, and as a kid, I was introduced to that, and that's why I sort of had this personal connection to it. So when they first launched X-ray observatories, it was like launch it and see the entire sky. And when they did that, they realized that there was a massive X-ray source, and they knew it was in Cygnus somewhere. That was it. And it got the name Cygnus X-1, X-ray source 1, hence its name. Tom Bolton, a staff astronomer at U of T and DDO, and that's the 74-inch telescope in Richmond Hill, which I had observing time on. He did his observations in the 70s, and he was able to actually zero in and identify the source. So he got the credit for it, and it's a binary star system with the black hole orbiting another blue giant star. And just as a off sort of character part of this, Tom Bolton, after his discovery, had his motorcycle license Sig X-1. So if you ever were driving around Richmond Hill and saw a guy on a motorcycle with that, it was him. And he was a transplant from the States, and he lived here and enjoyed his time.
I think we had Tom as a guest of honor at one of our meetings. I don't have my files with me here. But
I met him once, but him being here would have been before my time.
yeah, it was around 75 or 77.
And just
I'd have to look.
as I said, this is the 74-inch. It's really cool because that's up on the catwalk. So the observing floor is down below. You climb up using the ladder there and walk around, and you actually had to bend over and lift the scope up at the beginning of the observing run.
Why?
Because that's just how you didn't trust the motors on it. So
Like
it's the park position. At night you lifted it up and then you put it back down.
Like to help the motors lift it up.
No, you actually lifted
it up.
it. It was so gently balanced that you could physically move it.
Okay, cool.
So of course, Cygnus X-1, I'm not going into your part here. It's not a constellation night, but Cygnus X-1 is obviously not observable itself. but it is part of a binary system. So you can find that system. And it's just by Eta Cygni. So it's very close there. The system itself is only 7,000 light years away. Only 7,000. The black hole itself has had its mass updated through the years. It is currently estimated to be about 21 solar masses. When Tom was doing his research initially, it was down in the 15 solar mass period. The black hole and its partner star have a 5.6 day period. The separation between the two of them is only 0.2 AU, so 0.2 astronomical units. Mercury, for comparison, is 0.4. So its orbit is half of that of Mercury. And of course, as a black hole, I'm not getting into the physics of it or anything, but I'm just going to mention now that it produces relativistic jets. So as the accretion disk brings in material, what's happening is the magnetic field lines get all spoiled up and they get ejected perpendicularly to the plane. I said it is, of course, not observable itself. Its partner star is. So, to give an idea, there's Eta Cygni, there's the partner star. The circle is my 13 millimeter eyepiece on a 500 telescope. So easily identifiable. And there's a finder chart for it in the handbook, right there with north being up. So again, Eta Cygni, and just follow the few stars and you can find the partner star. As I was looking through information on this, I came across this interesting observation though. Some amateur astronomers down in the States were doing spectrographic and photographic observations. The partner star is so out of shape, it is actually pear-shaped. That as the two go around each other, the shape of the partner star changes its surface area as we see it. So the brightness of the partner star changes over time as we see the pear shape to the spherical backside. So we see the changing. And they were able to measure that difference in brightness. So a set of amateurs down in the States using just a 15-inch telescope and CCDs were able to witness and measure the period of the unseen black hole. I found that really cool.
Love the error bars.
I know.
You know it's science.
I know.
Now.
I don't have any context for how bad the error bars are, but it's there. And I also love the hand-drawn curve there.
How long will that star survive?
I didn't look into but it's been there for however long, so.
Let's lose the sun.
It'll die next week, no. So earlier, I mentioned the relativistic jets. And I mentioned the whole magnetic fields getting twisted. I found a really cool image or like illustration of what it looks like. So you can sort of see the twisting of those magnetic fields and the material just being ejected. But this is actually happening. So this is where I went down the rabbit hole. Oops. So over the course of several nights, I imaged the area. And you saw the image, but I didn't say what it was, because I knew I didn't want to spoil it. So the partner star is here. But before I go to the next slide, I want to draw your attention to that right there. That is actually the shock wave of those relativistic jets impacting on the gas in the area. So an amateur just imaged the effects of the black hole from just outside London. And as I said, that was me going down the rabbit hole. And this is in narrow band imaging, so light pollution, not an issue. So thanks.
Bill, questions?
Bill, we have a question.
Yeah.
Well, what's the source of the X-rays? How are the X-rays generated? You said the attraction, the reason it was
So,
stimulated was.
You've got the binary star system,
Yes.
and I don't pretend to have all the physics. But you've got the material from the blue giant being pulled off, falling into the accretion disk of the black hole. It's being pulled in, and again, just the gravity of it is twisting and exciting that material in the accretion disk. And it's following the path of the jets, of the magnetic fields, and being accelerated at, I believe the number was about 0.8 the speed of light, both perpendicularly from the accretion disk.
Yeah, Bill, I think the X-rays are generated by the collisions of the atoms of gas in that accretion, because as it spirals into the black hole, that gas is traveling at very high speed.
Exactly, point.
And I think that's why the X-rays are being generated. And then you get the magnetic field use, which accelerates the jets above and below this. But I think it's the collisions of the atoms of gas that they get so hot that they go beyond visible light and also.
Yeah, as I said, I'm not the physics person for this one.
I could never wrap my head around this, where the ejecti is coming out. And the gravitational pull being so great,
It's not
how can that happen?
because it's not happening at the event horizon. It's happening prior.
There's like a ball of gas, like it's just like on Earth, we have like the rocky surface of Earth, and then we have an atmosphere.
Right.
There's an atmosphere around a black hole. And so things are spinning into the black hole, but as they spin, they hit other things, just like we get storms and stuff. So those storms are going so fast that they hit something and they just so.
Yeah, because I could never wrap my head around that with the gravitational pull coming
Yeah,
from that.
the key is event horizon, the Schwarzschild radius. As soon as you get to that point, that's when you can't see anymore. But things outside of the event.
Outside the event horizon, yeah.
You can.
And you think of the M87 black hole picture, right? From a few years ago, you can see the black hole. And
Yeah.
all that stuff you're talking about, you can see that.
You can see it, yeah.
What confuses folks about it is that you think of things falling in, but things don't fall in if they're in orbit. And any more than if the Earth were reduced to the size of a peanut, the space station would still orbit the Earth.
Yeah.
The gravity would be so much more intense, but at the distance the space station is, still be in orbit.
Yeah.
And so the accretion disk can have stable orbits for individual molecules as they zip around. Now, if they lose energy, then they get closer and closer.
And they lose energy when they have collisions.
And that's how you get the kind of emission that comes from there.
I suggest, I don't know, I'm not a physicist either, but if you've got material which contains electrons rotating, they're gonna produce a magnetic field. Because when electrons travel, they produce a right angle magnetic field. Which could be, I'm speculating, could be accelerating other particles. I speculate.
The black hole itself is still very much under study. In terms of
Well, as you
what
said,
it's
it's
doing.
like it's been
Sequence
upgraded to 21 solar mass. It started out as like
15.
it was 15,
Yeah.
okay. Thought it was like 3 or 4 solar
No.
mass upgraded. All right, thank you very much, Bill. And so our next presenter is me. It's the constellation of the month. And this month we are doing Libra, the scales, not fish scales, like balance scales.
It's a weighty subject.
It's a very weighty subject. Weight, not mass. Bad pun. Somewhere here. Come on. First of all, let's get out of there. Of course, mine. Not up here. We need like a background person to do this. Oh, sorry, that's me. All right. Constellation from month. Libra, the weighing scales. Few interesting facts. It's the 29th largest constellation by sky area. It's not really surface area, but you think of the sky as a surface by surface area. Of the 88 constellations, its name in Latin means the weighing scales. It has no first magnitude stars, so it's one of more. It's a little bit harder to find in bright areas because of that. And its boundaries were officially set in 1930 by Eugene Delporte. He's a Belgian astronomer who discovered 66 asteroids in his time. And he lived till 1950, from I think 1870-ish till 1955. So this is not pre-computer era, but he died before computers became a big thing in astronomy. Next is location in the sky is right there. Oh, I mean, it's right around Virgo. It's surrounded by Virgo, Fucus, Lupus, Scorpius, and Hydra, and it's right along the ecliptic. If you're into the woo-woo, it's one of the astrology signs. And it's visible in both the northern and southern hemispheres. It's not one of the few, but there's not all the constellations are visible throughout the whole world. So this is one of those ones. Key stars are in it are that long Z word. Thank you.
And Zubenescamal.
Elf for Libre. It's a multiple star system. It's got a white star as well as a blue white star. It's known as the Southern Claw because Scorpius, right here.
There you go.
And the claws come out here and here, and so That's the southern claw. And then northern claw. Beta
How
Libra,
did you pronounce those names again?
Alpha Libre and Beta Libre.
You know that in 1973, and again in 1978, and again in 1980, London Center applied for summer grants.
Yeah,
And we hired our own members to do these summer programs, and the programs were called Project Zubin El Janubi.
Who named that?
Zubin El Janubi.
Sorry?
Who named that one?
Actually, it was one of, Eric will know the answer, because Eric was in on the first. And I don't know if Eric himself will take credit for picking that name, but we had some crazy guys in the club back then. I didn't say that.
Now, what, that name fall under an Egyptian name?
I am
It's
not
Arabic.
exactly sure. Yeah,
It's Arabic.
The Arabic, so
okay,
Al Janubi is basically towards the south,
okay,
and Al Shumari is towards
the
the
north, okay,
So basically they are, and I don't know what Subin means, but Subin is some sort of like. Could be wrong, but it's sort of like a indicator, that it's north and it's south.
okay, okay.
So these are like, of course, you have to find an English.
So it's, this one's to the north and this one's
So
to
you
the
can
south.
find each, can you identify a Alpha Libra?
E as,
So Alpha Libra, where is Alpha Libra?
this one is, I believe this one's Alpha Libre and this one's Beta Libre.
They're sort of like doing up
And
down.
E, I think, no, that's Sigma. I think that's Eta Libre.
So
Hang on, I got it.
according to the name, the name, the one Alpha should be in the north.
Right,
And then, sorry, the A should be in the south, yeah, so Janubi is south.
yeah,
So A is south and B is north.
The one on the right is Alpha.
yeah,
That's
Southern
And-
one.
so that's the southern claw, and it happens to be almost exactly on the ecliptic. And then the one that you saw pointing to at the apex of the triangle, there you go. You got it.
Alpha. Oh, Tau, yeah. Gamma. Sigma. So-
All the A is south.
All right, so there's also Barkuman, I think is how you pronounce it. Sigma Libre was formerly known as Gamma Scorpii, despite being well inside the boundary. So that's Sigma there. So I think Scorpius is over here. We already have like half of the constellation is already there, and then another Scorpius star. So, but
The reason is to satisfy the story,
yeah,
and that's exactly it. If you look at the name, the two claw stars,
yeah. So
they used to be part of Scorpio.
almost there. Foreshadowing.
Okay, now shut up.
It's okay. It's great interaction. It's great. But it was redesignated in 1851. Had the name of the guy that did it, but of course I didn't put it down. And so for a long time, it was Scorpii. Next, oh, wrong one. Next is deep sky objects. Gliese 581, that's this one right here. One of the first confirmed stars to have planets orbiting around it in that were potentially habitable. More research was done, found out it's not. And it's actually, so it's too hot to contain habitable planets, and the star is actually, it's about a third the size of our sun. So potential failed. NGC 5897, bright globular cluster, about 50,000 light years from Earth.
It's not very great.
it's ninth magnitude, brother.
And that's the one we're gonna be talking about later.
Oh, there you go. Foreshadowing. Unknown foreshadowing. And then NGC 5885. This one right here for you online. This one right here, which I guess there's only one galaxy up there. So, Barred Spiral Galaxy, discovered by William Herschel in 1784. And if I remember correctly, it's 2.3 megaparsecs from Earth. So it's a little, so it's a bit of a trek. All right. I had to like do Mediterranean mythology instead of just Greek because this isn't a very, there weren't many stories about the scales of justice, if you will. But Greek mythology, known as the claw of the scorpion, hence the sigma. And little comment there. So the claw of the scorpion, the southern claw of the scorpion right here, northern claw up here. So Scorpii. Also associated with the Virgo as the scale of justice, scales of justice, which is also associated. So Virgo and the Roman god Astera are both the same, sort of, and the goddesses of justice in their mythologies. The Babylonians were held the sun god Shamus, who was they also saw scales there, and he was the patron god of truth and justice. So might get more justice out of him. And then the Egyptians saw the three brightest stars. So I would assume these three, but it may be these three as a boat. It's pretty close to Antares. No. Yes. Antares for where it is, and Antares was kind of popular in Egypt, and so it could be the boat that brought the pharaohs to the heavens. Moving on, other cultures. Chinese associated with the azure dragon of the east. This one right here. Chinese astronomy or Chinese constellations are kind of large sky crossing things, so there's not really an individual like they don't have it nicely paired up like our constellations are. They're all the whole thing. So there's more associations with different parts of the sky as opposed to like a specific constellation. So the azure dragon of the east, it basically takes up the whole eastern sky. And then India, Vishka, I think is how you say that. Sorry if it's not. She was the chief, the chief female layperson for Migar Mata. Probably screwed that one up. Just gonna go with it. Literally Miga's mother. She built a monastery to Buddha, which is known as that, near that place. Savati is the best I got there. So, but it in the same way that The Chinese constellations take up all the sky. India's constellations are fairly similar in terms of all skyness. So that is everything. And we're going to talk about that, apparently. Oh, sure. There we go. I think that is. Oh, now we have. We'll do this. Dale, what's up? I'll get your.
Yeah, can you set it up?
Yes, I will do that right now.